Students, welcome to my YouTube channel PCM Academy and myself Pushit Mallik, MS in Physics. And today I will discuss about some problems based on wedge constants. In the last class I have discussed the basic concept of wedge constants, and I have told earlier that we will solve some problems based on wedge constants. And today's class is basically some problems on wedge constants, and I will solve these three problems. Okay. And the first problem is that it is a wedge, you can say, and the surface is actually inclined at an angle theta with the horizontal, and the object of mass m, here is the object of mass m, which will move along the horizontal, along the inclined plane. Okay, so if we put a block of mass m over here, and if the friction is, if the surface is frictionless, and all the surface we have assumed here are frictionless, so when this object of mass capital M sliding through the inclined plane, then the wedge will be moving towards this directions. Okay, so if we take this as a positive x direction, so it will move horizontally, which is nothing but the positive x direction. So the acceleration of this object capital M and the acceleration of the wedge of this wedge, that is the bigger mass, you can say. So the acceleration between these two blocks are related. Okay, so I have shown here by using the solid line its initial position, and by using the dotted line its position some later time. So when this mass will move from this point to this point, this point to this point, and at this time or within this time the wedge will be moving through this direction. So its initial position is here and the final position is here. So along x direction, I am assuming that it will move to a distance x. Okay, so along this direction, the movement of the wedge is x, and along this direction, the movement of this mass capital M is y. Okay, you can see here. So when the wedge will be moving to the distance x, then it will be moving to distance of y along this direction, because this object is here some later time. Okay, so we have to first find out the relation between y and x. So if we once find out the relation between y and x, that is the displacement relation actually, then we can easily find out the acceleration relation. Okay, so here from this diagram you can easily say that as this angle is theta, this angle will also be theta. So x and y are related as nothing but y is equal to x sin theta, you can say. Okay, so the acceleration along the y direction, so this direction I have taken here, y direction, and this is the acceleration of this mass capital M. So let me use for this small block as small a acceleration. So here the acceleration will be proportional. If we take derivative two times like this, as theta is constant here, so if we take derivative, that is dy by dt will be dx over dt into sin theta. So this will give you the velocity relation, because dy by dt is the velocity of this mass capital M along this direction. So that will be nothing but vy, and this is dx by dt is the velocity of the wedge along this direction, that is, let me take it as capital Vx sin theta. And if we take again differentiation with respect to t, then we will get ay will be ax sin theta. Okay, so this is the acceleration relation. Okay, this is the acceleration relation between these two objects, and the acceleration of one object is depends on others. Okay, so this is actually the constant equation. This is the restriction of motion, that the acceleration of these two objects are related by each other. Okay, so similarly by using these concepts we can solve this problem also. And here what we have to do, we have to find out the acceleration of this mass small m, and you can see here that this acceleration of this mass small m is totally depend the motion of the mass capital M, and the motion of the mass capital M we have discussed here. So we can use this result. So along this direction, what is the acceleration of this block? The acceleration of this object capital M, you can see the acceleration of this block capital M along this direction is nothing but x sin theta. Okay, so what is the AY? So this is AY, and if we take this AX, okay, this AX, let me take it as A. You can take it as A, so it will be A sin theta, simple A. Okay, so what will be the acceleration of this mass small m? So the acceleration of this mass small m will depend on the acceleration of the mass capital M. Now what is the acceleration of capital M? So capital M has two acceleration component. One is along the inclined plane and another is along this direction that we have discussed here. Here we don't discuss along this direction because we don't need to do this to find out the constant relation. Okay, so along this direction, the acceleration of this object along this direction is independent. Okay, and this is due to gravity, and the acceleration will be g sin theta, you know. So here you can see from this figure what will be the acceleration of this mass small m. The acceleration of the mass small m is totally dependent on mass capital M, and the capital M has two acceleration direction, two component of acceleration. One is along this direction and another is along this direction. Okay, so and this mass small m is actually moving vertically downwards, so we need to find out the acceleration along downward direction, along vertically downward direction, and that will be nothing but the component of AY and the component of X, because the acceleration of this mass small m will totally depend on the acceleration of mass capital M. So the acceleration component of AY along this vertical direction is, you can say, AY cos theta, and for this, if this is theta, so it will be 90 minus theta, and you can easily find that if this angle is theta, so this angle is theta, so this angle will be 90 minus theta. So for this acceleration along y direction, here actually we have taken this as y direction, and okay, this is y direction and this is x direction, this is x direction, this is the x direction, this is the x direction, and this is the y direction. Okay, perpendicular to this, of course. So this is the y direction. I have taken this as y. Okay, oh, you don't need to do here the, actually we don't need actually here the coordinate axis. Okay, we don't need here coordinate axis, just this is y, so this is y, this is y along this direction. Okay, so but here this ax and ay are perpendicular to each other, so the component of ay along this direction is cos theta, ay cos theta, and along this direction x sin theta, so it will be x sin theta. Okay, so this is the acceleration of the mass small m along vertical downward direction, that is ay cos theta plus x sin theta. Okay, so the acceleration of mass small m is depend on the acceleration of mass capital M, and the capital M has two components, one is x and another is ay. Okay, and ay can be found from this relation, that is x sin theta. Okay, so this is depend on the acceleration of this object, this wedge. So all are related to each other. Okay, we don't need to here represent small a also. Okay, we don't need to represent like this. So this is ay is equal to x sin theta, and this x sin theta can be used here as ay for the acceleration of mass small. Okay, so this is how we can relate the acceleration between the objects by using the constants condition. And the third one is, here we have to find out the acceleration of this object, and here also when this object is moving downwards and the wedge will be moving along this direction, this horizontal direction. So if this is the initial position, by using the solid line I have shown here, and by dotted line I have shown the lateral position. Okay, so the initial position, so it will move through the x axis x, and in that time this object will be moving a distance of y, So what is the relation between x and y? We can easily find out from this triangle that tan theta will be y by x. So here tan theta will be y by x. So you can see y is equal to x sin theta, x tan theta. So again, if we follow this process, we will get ay is equal to x tan theta. Okay, so this is how we can relate the acceleration between the objects. When one object, the motion of one object is depend on the other object. Okay, so you can use these kinds of relation to solve the problems. Okay, so these are actually the first step to solve the problems, constancy equation. Then we have to use the Newton's law to solve problems. But this is the first step, writing down the constancy equation, that is the acceleration relation between the objects. Okay.